The fractions are related with the divisions we see in our daily life, but we are used to watch them in a more visual way, such as 3 out 4, 2 out 7, and as we can see here, they are divided into two parts. On the one hand, we can find the denominator, which refers to the number in the upper part of the fraction, and it shows the number of pieces we take from the entire one. On the other hand, we have the denominator, which is in the downside, and it refers to the quantity of parts which all of it is divided.
Well, before answering to this question, we are going to represent them graphically. So let's remember that the denominator represents the number of pieces in which the total of the circle has been divided, as well as the numerator refers to the quantity of pieces we take. In the fraction of the left, 1 out of 2, we can see that the circle is divided in two parts. And in the one of the right, 2 out of 4, we have divided it into 4 pieces. Now we are going to see the number of parts we take in each circle. In the first one, the fraction tells us that we have to take one of the two parts, and that's why we paint one of them. And the fraction of the right indicates us that we have 2 out of 4 parts, so we paint 2 of them.
As we can see in both of them, they have the same proportion of the surface painted, so they are equivalent, and they represent the same value. In both of the cases, we have painted the half of the circle, without taking into account the quality of the pieces. If we divide the circle in 8 parts, we will have 4 of them painted, and as you can see here, the fraction is the following one, 4/8. As we can prove here, the fractions are equivalent, because although we have divided the circle into more pieces, we still have the same proportion of them painted.
Now we are going to work with two other fractions, 6 out of 8 and 12 out of 16. And what do we have to do if we want to know if they are equivalent? One way of knowing that is by drawing graphically, but there is a faster and more simple way. We have to do a cross multiplication in which we have to multiply the numerator of the first one with the denominator of the second one, and vice versa. The denominator of the first fraction with the denominator of the second one. After calculating it, we have to prove if the answers are the same. And in that case, we will have two equivalent fractions. In this case, both answers are 96, but if the answer is composed of different numbers, it means that those fractions have not the same value. Let's see another example. 4 out of 6 and 8 out of 10. 4 multiplied by 10 equals 40, and 6 multiplied by 8 equals 48. So, as they have not the same value, they are not equivalent.
Once we have learned all of this, we are going to work on how to obtain equivalent fractions. Sometimes we need to look for another equivalent to the main one, and there are two different methods to reach that: amplification and simplification. But first we have to prove that the two fractions are equivalent. In this case, there weren't. Amplification method. For example, we have a fraction that is 2/4, and we are going to use amplification method to get an equivalent one. This method consists on multiplying both the denominator and the denominator by the same number. In this case, 2 times 2 divided by 2 times 4. That equals 4/8. On the other hand, in the simplification method, its basis is the same, but instead of multiplying, we are dividing them by the same number, the denominator and denominator. However, we have to take care of the numbers they can get divided by, because they must be divided by the same number. For example, let's imagine we have 10/15ths, and both numbers cannot get divided by 2 or 3, so we are going to divide them by 5. This means 10 divided by 5 is equal to 2, and 15 divided by 5 is equal to 3. That equals 2/3.